All right, so number one on our worksheet, a lot of students want to look at it and start, just because we've been talking about the possible rational roots, and that's what most of this worksheet is. They want to look over here and say, what's the constant term? And it's -8. But that's not true. It's not a constant term. It has a variable with it. So you might even say, okay, well, the constant term then is 0. So what are factors of 0 you're going to place in the numerator above factors of our leading coefficient 1, which would be plus or minus 1. Well, the problem with doing it that way, well, there's an infinite amount of factors to 0. Like you can have 0 times 5, 0 times 100, 0 times -22. I mean, just there's too many to list there, and you're not really narrowing down that field that you can guess and divide out with using synthetic division. So what I like to say is, before I try this whole thing with finding rational zeros and dividing, I like to look at it and say, can I factor it? Because I'd much rather factor something and find the zeros than to have to go through that possible rational roots and then start synthetically dividing, just because it can take a while. So when we look at this, we say, yeah, you know what? We can factor this. We've got x cubed minus 2x squared minus 8x. And notice we have an x in common. So you can factor out x, and you get x squared minus 2x minus 8. And now we have a trinomial here in the middle, and we know we can, let's see if we can factor that there. We've got factors of -8 that will add up to -2. I know 4 and 2 multiply give me 8, so I can make one of them negative. I'll make the 4 there negative, so it adds to give me -2. Now the leading coefficient here is 1, so I can take the shortcut and say this trinomial factors to x minus 4 times x plus 2, and don't forget times x right there. These are my factors right here. Now I need to come up with the zeros based on those factors. So the zeros, I'm going to set each factor equal to 0, so I get x equals 0. When x minus 4 equals 0, x must be 4. And when x plus 2 equals 0, x must be -2. So those are my zeros. Now when I go to sketch a graph of this, I'm going to erase some of these stray marks over here. When I go to sketch a graph of this, I need to pay attention to more than just my zeros. But I'm going to go ahead and just plot those points right here that are my zeros. I've got x equals 0, x equals -2, and x equals 4. I also have to think about my end behavior. So I know that end behavior is all based on that first term there. And the coefficient here is a +1. So whenever the leading coefficient is positive, we know on the right side the end behavior is going to be going up. The next thing to look at is that exponent right there. If the exponent is even, then the left side would match the right side. But it's odd, so the left side is going to be going opposite. Now I'm just putting these red arrows here to kind of remind me when I go to start sketching the graph the way the end behavior should be. So with my end behavior taken care of, I've got my factors, I've got my zeros. I want to make sure that I look at my y-intercept. And so the y-intercept happens when x is equal to 0. So here's my function. What is the f of 0? Well, 0 just makes that go away. 0 makes this goes away. 0 makes this go away. We just get 0 because everything in here, not, I guess going away is a bad way to put it. Everything becomes 0. 0 cubed is 0. -2 times 0 squared is 0. -8 times 0 is 0. So all of this just becomes 0. So it tells me my y-intercept is 0. So when x equals 0, y equals 0. And if you think about it, that makes sense because I've already graphed that. You can't have another y-intercept because then you don't have a function. So I've got my factors, I've got my zeros, I've got my y-intercept. I also want to pay attention to my multiplicity. So look at each factor and say, where did that, each zero, and where did that come from? Which factor? So x equals 0 came from this factor right here. It's listed once. 1 is an odd number. So I know that when the multiplicity of it is an odd number, it goes through at that 0. X equals 4. It came from x minus 4. there's not another like x minus 4 times x minus 4, so it's just listed once. That's an odd number, 1 is, so it goes through. And the same thing for x equals negative 2. It came from the x plus 2, listed once, it goes through there. And so now I'm going to sketch this thing. I know it comes from down here. It's going to go through the negative 2. It's going to come back down and go through the 0. And then it's going to go back up and go through the 4. Now, some people ask me, like, do I care about where this minimum is or this maximum is? No, you'll learn that later on. But for right now, I just want you to pay attention to where your zeros are. The multiplicity, meaning does it go through those zeros or does it bounce? The end behavior, and where the y-intercept is. I think that's enough for you to keep up with right now without having to learn where the max and the min is. You'll see some teachers, and it's okay if you want to do this, they'll tell you to draw dashed lines through here, just so we know it's not certain where that is. And so you can do that if you want also. So for number 2, when we go to look at this to factor it, my first thought is, hey, can I factor it by grouping? So I have x cubed plus 7x squared plus 7x minus 15. And if I try to factor this by grouping, say, okay, I've got an x squared in common. That leaves me with x plus 7. And then what do I factor out here? Well, I can factor out pretty much just a 1. And so to factor this like this is going to be pretty complicated. So here is where it is helpful to be able to do some division. So we need to come up with our possible rational roots. And so that is found by saying, what are factors of negative 15? So if you want to do it, a little bit longer way this first time around, we say factors of negative 15 can be 1 and negative 15. It can be negative 1 and positive 15. It can be 3 and negative 5. And it can be negative 3 and positive 5. And so those are all my different factors, and we typically don't write it out like that. Usually we say plus or minus 1. That takes care of this negative 1 and the positive 1 at the same time. Plus or minus 3, plus or minus 5, and then plus or minus 15. And so those are all my possible factors of that constant term. And then we're going to put it over factors of that leading coefficient, which is just 1. So you can have 1 plus or minus there, or factors of a positive 1. You have 1 times 1 or negative 1 times negative 1. So we include both of those. Now this makes it pretty easy since the bottom number is 1. My factors are just going to be, or my possible rational roots are just going to be the numbers that are in the numerator there. So you're going to have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Now, what do we do with that? We've got to divide it into this right here. So for instance, if I think 1 is a 0 of this function, I know that at most I'm going to have 3 of these be zeros, but let's see, if 1 is one of them, then it will, x minus 1, we'll be able to divide into that. I know if 1 is a 0, x minus 1 is a factor. So we're going to divide this synthetically. Make sure that your function is going 3, 2, 1, 0. It's in what we call descending order. And then you can write out the coefficients. 1, 7, 7, and negative 15. Drop the first 1. Multiply. 1 times 1 gives me 1. Add. 1 times 8 gives me 8. Add. 1 times 15 gives me 15, add, and I get 0. So this made it nice. I know that my first try I got it right. I've got a 0 as the remainder, which means that if you put 1 into this, you get 0 when you take the f of 1 here. So x minus 1 must be a factor. And so I'm going to write it down below. I'm going to say x minus 1 times, well, it was x cubed. This is going to become x squared, x. These are all positive, and this is going to be the function that's going to be put right here next to it. So x squared plus 8x plus 15. just to clear out room now, I'm going to erase this so that way I don't gunk up the screen. So you have the option to back it up and watch it if you want to. Write it down if you need to. And that way we got a little room to write here. So I've got this trinomial here. I'm going to factor it. You don't have to factor it. You can keep dividing it out with all those possible roots that we came up with, but it's a lot quicker just to factor it, especially if you're on a time test or something. So we got factors of 15 that add up to 8. Oh, look at that, 3 and 5. The leading coefficient is 1, so I can take the shortcut and say x plus 3 times x plus 5 is what it factors to. I've got an x minus 1 there. These are my factors, which means I need to come up with my zeros now, and that's just setting each factor equal to 0. So I get x equals 1, x equals negative 3, x equals negative 5. There's my zeros. Don't forget we got to come up with our end behavior over here. The leading coefficient is positive, so the right end's going up. The exponent on that first term is odd, so that means the left side is going to be opposite of the right, so it's going to be going down. Find your y-intercept. So your y-intercept is where it crosses the y-axis, so it's when x's value is 0. If I put 0 in here, this becomes 0. 7 times x squared, it becomes 0. 7 times x becomes 0, and I'm just left with negative 15. So when x is 0, y equals negative 15. That's going to be way down below here, so I'm not going to show anything crossing the y-axis on this graph right now. And so when I go to graph, I'm going to plot my points. I got x equals 1 is a 0. I've got x equals negative 3 and x equals negative 5. Now I need to know if is it going to go through that negative 5, is it going to bounce? Let's look at the multiplicity. X equals 1 came from this factor. It's only listed once. That's an odd number, so it goes through. X equals negative 3 came from this factor. That's listed once. That's an odd number. It's got to go through there. X equals negative 5 came from this factor, listed once. It goes through. So these first two examples we did, it's going through each time. We'll see some that bounce here in a little bit. So when I go to graph this, it's going to come from down here, go through. I don't know exactly how high it's going to go up, but it's going to come back down. I know that it doesn't cross the y-axis until negative 15, and then somewhere in here it comes back up, and it goes on forever like this. And that's number 2. Let's go to number 3. So for number 3, let's look at this. Is there a way we can factor it by maybe grouping? We can try that first, but you know, I can already see that 23 and 6 don't have anything in common. And if I factor out x squared here, I'm not going to get anything matching the 23. So we're going to go ahead and write out our possible rational roots on this. So factors of 6, I've got 1, 2, 3, and 6, and these are all plus or minuses. And then I'll list out factors of 8. So this is all going to go over, it's here, factors of 8. We got 1 and 8, and 2 and 4. Now I've seen it done sometimes with a chart. When we write these out, I'll show you what I mean by that in a second, but this can be pretty lengthy because we got 1 over 1, 2 over 1, 3 over 1, 6 over 1, and then negative 1 over 1, negative 2, and so forth. Then we got 1 over 2, 2 over 2, 3 over 2, 6 over 2. It can be, it's a lot of factors here. So some people do it like this. They make a chart. And they write this out. This is plus or minus, and we got 1, 2, 3, and 6, and then this is our numerator, the factors of the numerator, and then the factors right here listed in the denominator go like this: 1, 2, 4, and 8. And so we got 1 over 1, which is 1, 2 over 1, 2, 3, 6. 1 over 2, that has not been listed yet, so you got 1/2. 2 over 2 is 1, that's already been listed. 3 over 2 has not been listed. 6 over 2 is the same thing as 3. 1 over 4 is 1/4. 2 over 4 is 1/2. That's already been listed. 3 over 4 has not been listed. 6 over 4 reduces to 3/2, so that's already been listed. Then we got 1/8. 2 over 8 is 1/4. That's right there, already listed. 3 over 8 has not been listed. And 6 over 8, that reduces to 3/4. That's been listed as well. So this isn't like an appropriate listing for me if I'm asking what are the possible rational roots. I would write those out like this. This just kind of keeps you from repeating them and keeps them organized. I say plus or minus 1, plus or minus 2, 3, 6, and then fill out the rest from the chart here. Keep going with that. Plus or minus 1/2, 3/2, 1/4. I'm going to run out of room, aren't I? 3/4. I'll just start over here. Plus or minus 1/8. And then plus or minus 3/8. Lots of roots there. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positives, 10 negatives. That's a total of 20 different possible roots that we could have. Hopefully, we come across one without having to divide out all of them, which I know we will. So with those listed, I'm going to just erase this. Once again, you can back it up if you want to watch how we got that. And I'm going to use synthetic division to divide this out. Now I've got 3, 2, 1, 0 going on. So that's good. I can write down the coefficients, 8, -6, -23, and 6. And I'm just going to start with 1. See if that goes into it. So drop the 8. Multiply. 1 times 8 gives me 8. Add. Multiply. Add. Multiply. And when I add here, I know I'm not going to get 0. So I'm going to start over. This time I'm going to make it -1. So when I multiply here, I get -8. Add, I get -14. Multiply, I get +14. Add, I'm going to get 9. Multiply, I get -9. And then I get -3 as a remainder. So -1 didn't work. So let's try again. And I know the answer, but I'm not going to just take you through it knowing the answer, because that's not fair. You're not going to know the answer when you go to do these problems. So +1 and -1 are out. Let's look at +2. So drop the 8, 16, add, we get 10, 20, -3, -6, add, I get 0. So there we go. So I know that 2 is a 0. That means that x minus 2 is a factor. And so if x minus 2 is a factor, I can rewrite all of this as x minus 2 times, this would be 8x squared. This is going to be x, and that's going to be -3. So we got 8x squared plus 10x minus 3. And just in case you didn't see the first two, the reason why I chose that to be squared, because it's 1 degree, 1 power less than the original function. Once again, clearing out room, I'm going to erase this up here now. You don't erase it though. Show me your work on your quiz. It's just, I try to keep it all on one screen while we're working through these. And I'm going to see if I can factor this right here now. So let's see. 8 times -3 is -24. I want factors of that add up to 10. Looks like 6 and 4 would add up to 10. Multiplied though they don't give me -24. 2 and 12, they multiply to give me +24, add up to give me 14. But if I make the 2 negative, now they multiply to give me -24, and they add to give me +10. So I can't take the shortcut here because the leading coefficient is not 8. So I'm just going to say -2x and 12x's. And I'm going to factor these by grouping. So I'm going to pull out I'll start over here. Pull out a let's see, we got a 2x in common, so I end up with 4x minus 1. And over here I'm going to pull out a 3 that's in common, and I get 4x minus 1. Notice what's in the parentheses is the same. That tells me I'm on the right track. So factor out a 4x minus 1. So this term divided by 4x minus 1 gives me 2x. This one divided by 4x minus 1 gives me 3. And don't forget, we originally factored out an x minus 2. It's got to come down here next to it. And so now I have my factors. So these are my factors. I need to come up with my zeros. So once again, clean up all this work. I'm going to just erase it so we have our factors now. Let's move these up. So these are my factors. Let's list out our zeros. So the zeros on these are a little bit more work than we did in the last ones. Not too much. X minus 2 equals 0 when x is equal to 2. For this one, 4x minus 1 equals 0 when? Well, solve for x. So 4x equals 1, or x is equal to 1/4. 2x plus 3 is equal to 0. Solve for x. X equals negative 3/2. So there's my zeros right there. So with the zeros solved for, I'm going to just go ahead and plot them. They're at 2, 1/4, which is about right there, and negative 3/2, which is about the same thing as negative 1/2, or it is the same thing as negative 1/2. But I need to know the multiplicity. 2 came from this factor, it's listed once, it goes through there. 1/4 came from this one, listed once, that's odd, so it goes through. Negative 3/2 came from this one, listed once, it's odd, it goes through. So it goes through on all three of those. Pay attention to your y-intercept. So where's your y-intercept? You find that by putting 0 in for x. When I put in 0 here, this becomes 0. So does this, so does this, and I'm left with just plus 6. So when x is 0, y is equal to 6. So plot that y-intercept at 0, 6. Just to pay attention to our end behavior, let's make sure we know that. The leading coefficient is positive. That means the right end is going to be going up. The exponent there is odd. That means the left end is going to be opposite it. So it's going to come through here, go through my first 0. I don't know exactly where the maximum occurs. It doesn't have to be on the y-intercept. It could be like this and then coming back down. It could be going through there. Like I said, I'm not worried about that right now. It's going to come back down and go through this spot, and then it's going to shoot out through that. It goes through at each 0 here. It's going to be going through. And notice the end behavior matches. Let's look at number 4. So for number 4, once again, we can't really factor this out. So I'm going to look at my possible rational roots. So to do that, I'm going to list out roots of 15. I've got 1 plus or minus 3, plus or minus 5, and plus or minus 15. I'm just going to go ahead and make my chart because I notice this is not a 1. So I've got plus or minus 1 and plus or minus 2 right here. So all of these just come down when I divide it by 1. So I could have 1, 3, 5, and 15. All plus or minus here. And then I'm going to go through and put everything over 2. So I could have 1/2, 1/3, 1/5, and 1/15. All of those could be plus or minus. So if I list out those possible rational roots, once again, plus or minus 1, 3, 5, and 15, and then my fractions. You don't have to do this chart, just for some it helps them to think of it like that before they list it out. Plus or minus 1/15. Barely get in over there. I don't think we're going to get to this side, but you never know when you start dividing out these things. This is in descending order. It goes 3, 2, 1, 0, so I don't have to worry about putting in any placeholders. And so I'm going to write out the coefficients: 2, -5, -28, and 15. This time I'm going to try out to see if 1 is a 0. Bring down the 2, multiply 1 times 2, add, 1 times -3, add, multiply, and when I add that I get like -16, so it's not going to be one of the zeros. So let's go back, and I'm going to try out -1 this time. So drop the 2, multiply, add, multiply, and then add, multiply, and add. I get 36. That's not a 0, so that knocks out the 1 here. I did +1 and -1. That kind of stinks. It's always nice when 1 is a factor, or x minus 1 is a factor, or x plus 1 is a factor, just because it's nice and easy to synthetically divide that number. Let's try out 3. So drop the 2, we get 6, add, we get 1, 3, -25, and then -75 isn't going to do me any favors there. Let's try -3. Like I said, I know the answer. I could just go through and work that out, but that's not how you get to do things, is it? So let's try it the same way you get to do it. So this gives me -6, add, we get -11, +33, add, we're going to get +5, multiply, we get -15, add, we get 0 here. That's what I'm going to see, a remainder of 0. That tells me that -3 is a 0. And it also tells me x plus 3 is a factor. So I've got x plus 3, and I basically took x plus 3 and divided it into that function. And I got this right here as my quotient, 2x squared. It's going to be 1 less than the original one. 2x squared minus 11x plus 5, and then the remainder of 0 just kind of goes away there. So let's erase this. I'm going to drag these factors up. And let's see if we can factor that trinomial that got left over here. So 2 times 5 is 10. And I want factors of 10 that add up to the middle term, -11. So it looks like it's going to be -1 and -10. Multiply, give me a +10. Add to give me a -11. Unfortunately, I can't take the shortcut because that first coefficient is not 1. So I'm just going to break it up like this, -x and -10x. Bring down my 5, bring down my 2x squared. And then I'm going to factor by grouping. Factoring out an x, I get 2x minus 1. Factoring out a -5, I get 2x minus 1 also. And so then I can factor out the 2x minus 1, and that leaves me with x minus 5. And then don't forget, you originally factored out that x plus 3. And so right here I have my factors. So, erasing all of this to give me some room to write. Now we know our factors, now we can find our zeros and start graphing this thing. So these are my factors. What are my zeros? The zeros are taking each factor and setting it equal to 0 and solving for x. X plus 3 equals 0 gives me x equals -3 as a 0. You set this one equal to 0 and solve for x, you should get x equals 1/2. Set this equal to 0, solve for x, you should get x equals 5. Those are my zeros. I can go ahead and plot those zeros if I want. -3, 1/2, 5. When I talk about multiplicity of those, I'm saying how many times is the factor that it came from listed. This one is listed once, which means it goes through. It's an odd number. This one's listed once, where we got 1/2 from, so it's an odd number, it goes through. Same for this one, listed once, odd number goes through. Pay attention to the end behavior. So for the end behavior, I know the first number is positive. That means the right side's going up. The degree of the function is odd, so it goes opposite the right side. It's going to be going down. What's my y-intercept? So the y-intercept is found when we put 0 in for x. You put 0 in for x right here, you're going to be left with a positive 15. So when x is 0, y equals 15. That's going to be way up here, past the 10. So what I'm going to do is, I'm ready to graph it now. I know it's going to come from the bottom. This is just straight point right there. But I know it's going to be coming from the bottom right here. It's going to go through. It's going to cross way up at positive 15. Then it's going to come back down, probably pretty sharply. And then it's going to sink back down and go back up and go through there. So it's going to go through, come back down, super sharp here. Not quite a vertical line because then it wouldn't be a function. And then it's going to go back through at 5 right there. Try to do your best. That's not very pretty. I'm going to redraw that. Let's see if we can send it through 5 a little bit better. And then it's going up. Once again, I don't care where this min is. The only reason why I drew my max so high up because I know where the y-intercept is. So it kind of gives me a better idea of the shape instead of just drawing it crossing somewhere where it doesn't really cross there. All right, let's look at number 5. So for number 5, looking at, I don't see where factor by grouping is going to work. So I'm going to list out possible factors of -3. We have plus or minus 1 and plus or minus 3. And then factors of 6, we got plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3. So when I list all these out, I'm going to have 1 over 1, which gives me plus or minus 1, 3 over 1, which gives me plus or minus 3, 1 over 2 gives me 1/2, 3 over 2 gives me 3/2. And if you're doing this chart, you don't have to write plus or minus in every spot. It's just at the end, when you're giving me your answer, what are the possible zeros, make sure you put plus or minus with it. I've got 1 over 3 right here, 3 over 3, which is 1. 1's already listed. 1 over 6. And then 3 over 6, same thing as 1/2, it's already listed. So these are all my possible rational zeros there. So writing those out, we've got plus or minus 1, plus or minus 3, plus or minus 1/2, 3/2, 1/3, and 1/6. Oops, eraser, not pen. And so now I'm going to start my synthetic division. This is listed as 3, 2, 1, 0. So I can go ahead and just write out the coefficients. I've got 6, 19, 2, -3. And I'm going to start with positive 1. Hopefully that will work. Drop down that 6. Multiply and add. Multiply and add. Multiply and add gives me a remainder of not 25, 24. Still not 0 though, so that's not what I want. Let's try, give me a little more space this time. Let's try -1. Drop the 6, we get -6, 13. -13 gives me -11. Positive 11 gives me positive 8. That's not it. So positive 1 and -1 are not zeros of this function. So next I'm going to try 3 to see if 3 will help me out. So multiply, whoops, I'm saying 3 and writing down 3. That's not good. Drop down to 6, we get 18. Adding, we get 37. Multiply 3 times 37. This is getting nasty already, isn't it? 3 times 37 is 90. 90 plus 21, which is going to be 111. Add, I get 113. 339, and that's not going to be 0. So 3's out. Let's try -3. Like I said, I've got the answer, but I haven't looked at it in a while, and it's not very fair for me to know the answer and just go straight to the factor when you've got to do this when you're doing it. This gives me -18, adding gives me positive 1. -3, adding gives me, what, -1. Multiplying here gives me positive 3, adding gives me 0. Seems like every time I say that, I find the 0, so maybe I should start saying that. So negative 3 is a 0. That means that x plus 3 is a factor. It's the opposite there. That also means that this is 6x squared. That's 1x. And that's negative 1. And the remainder of 0 kind of goes away there. So if I'm moving through this kind of fast for you and you're like, I have no clue what he's doing, watch one of the first 4 I did. If you skipped along to this point in the video, it means you need help with the slower version of me, which is the first 4 examples I gave. These get kind of repetitive after a while, so I don't want to go slow through them all. I kind of speed it up as we go through these. So, can I factor this? Do I have factors of negative 6 that will add up to the middle term positive 1? 2 and 3 should work, with the 2 being negative. Once again, leading coefficient's not 1, so I've got to split that up into negative 2x and 3x. And then factor by grouping. So I'm going to factor out 2x, and I get 3x minus 1. And then just factor out a 1 here, I get 3x minus 1. So I get 2x plus 1 times 3x minus 1. And don't forget you factored out an x plus 3 earlier. So these right here are my factors. Now I can find my zeros, start talking about end behavior. So remember, if those are my factors, what are my zeros? I'm going to have set each factor equal to 0. You get x equals negative 3, x equals negative 1/2, and x equals positive 1/3. So you can go ahead and graph those zeros now. You've got negative 3, negative 1/2, and positive 1/3. So with that set up, let's make sure that we're checking what our y-intercepts are. So we got y-intercept. If I put 0 in here, I know it's crossing at negative 3. Let me try to graph that in green to be a little bit more consistent. So there's not a whole lot of room here to graph this. Just do the best you can. But we do know that at 0, negative 3 is a y-intercept. Let's pay attention to our end behavior. This first term is positive. That means the right side goes up. This is odd. It goes opposite the right side. It's going to go down over here. We need to pay attention to our multiplicity. So at each factor is only listed once. That means each one of my zeros is going to be going through when I graph it. So I'm going to start down here, I'm going to come up and go through, and then fall and go down through here. I don't know if negative 3 is the minimum, but it's such a tight spot, I'm going to make it the minimum, and it's going to go out that way. Notice it matches up with my end behavior, and it goes through my zeros. Number 6. Number 6 almost looks like you could factor it like a trinomial, but notice this is a cube. And this is a square. It's going to be a little difficult to do that, so let's divide that one out too. Start by listing out your possible factors of negative 4. You've got 1, 4, and 2 times 2. So you get plus and minus each one of those. And then list out your factors of 1. Well, you just got plus or minus 1 there. So actually, I wasn't even paying attention to what the leading coefficient was. I didn't have to really write out all that. My factors are plus or minus 1. Plus or minus 2, plus or minus 4. Not factors, but possible rational zeros. I'm recording this pretty late, so I'm saying things I don't mean to say sometimes. With that being said, let's do some synthetic division. Now this goes 3, 2, and then we're missing 1. So I'm going to treat it, let me write this out, I'm going to treat it as if it were x cubed plus 3x squared plus 0x. You just got to go 3, 2, 1 in our exponents, and then we got x to the 0 there. So 3, 2, 1, 0. Now I can list out those coefficients. 1, 3, 0, negative 4. And I'm going to try to divide it by 1 first. 1 times 1 is 1. Add, multiply, and I get 0. So that's good. First try on this one, and we get it right here. We know that since 1 is a 0, x minus 1 is a factor. This is going to be 1 degree less than the original function, so it's going to be x squared plus 4x plus 4. And then I'm going to factor this trinomial I get down here. So factoring the trinomial, we want factors of 4 that will add up to the middle term, 4. So we got 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. There is a 1 as the leading coefficient, so I can take the shortcut. And so this is going to factor to x plus 2 times x plus 2. And then I have x minus 1 right here. These are my factors. So what are my zeros? So the zeros are going to be, set each factor equal to 0. You got x equals 1 and x equals negative 2 and x equals negative 2. So I don't have to list that twice. Let's go ahead and graph those zeros. You got x equals 1. Oh, my wrist is putting all sorts of marks on the board here. You have x equals 1 and x equals negative 2. Look at the multiplicity of each. X equals 1 came from this factor. It's listed once. That's an odd number, so it goes through. X equals negative 2 is listed twice. So since it's listed twice, 2 is an even number. That means this one has a multiplicity that's even, and it's going to bounce. And then let's check our y-intercept. If I put 0 in for x over here, I get, that becomes 0, this becomes 0, I get negative 4. So that tells me that at negative 4, when x equals 0, y equals negative 4. So I kind of get an idea of how it's going to start to look, but let's check our end behavior. The leading coefficient is 1. That's a positive number, so it's going up on the right side. And the degree of the function is odd, so it's going to be opposite of that. It's going to be going down on this side. So as I go to graph this, at negative 2 it bounces. So it's going to come from down here, like this shows, bounce right here, go through the negative 4, and then through the 1 right there, and match up with this. Is negative 4 the minimum? I don't know. It could come down like this and go through. In fact, let's try to draw it like that, because it doesn't have to be the minimum in there. There we go. So the end behavior matches up, and so does the multiplicity. This is what I mean by bounce. It's our first example where it actually bounces on this worksheet here, and then it goes through. Number 7, we've got x to the 4th minus 5x squared plus 4. This one is missing a couple of them. Let's write it out so that it goes in descending order. X to the 4th plus 0x cubed minus 5x squared plus 0x plus 4. So this one skips from 4 to 2 to none, and now I've rewritten it so it goes 4, 3, 2, 1, 0. And then now we can divide this thing out. So I want factors of 4 written out first, and so I got plus or minus 1, plus or minus 2, and plus or minus 4, just like the last one there. I don't have to worry about dividing it out because the leading coefficient is 1. So let's write out those coefficients: 1, 0, negative 5, 0, and 4. And then I'm going to try positive 1 first, so drop the 1, multiply and add, multiply, add. Oh, look at that. First try. That was very nice of whoever wrote that problem to let you have it on the first try. So the 0 is 1. That means x minus 1 is a factor. And since the degree is 4 here, this is going to be x cubed right here. So it's going to be x cubed plus 1x squared minus 4x minus 4. And so this mess factored to this right here. And hopefully, when I move this up, we'll be able to factor it by grouping and won't have to divide again. But sometimes you got to divide again. Let's see what happens. So if I were to try factor by grouping on this thing, I got 4 terms. I'd group these two and these two. Factor out an x squared, you get x plus 1. Factor out a negative 4 right here, you get x plus 1. What's in the parentheses matches, which means I'm good with factoring out an x plus 1 now. So it did factor. So factor out an x plus 1, and this divided by x plus 1 leaves you with x squared left over. This divided by x plus 1 leaves you with a minus 4 left over. Don't forget we factored out an x minus 1 right here. Now this one is a difference of squares, so it can be factored to x minus 2 times x plus 2. And then we have x plus 1, and we have x minus 1. So this is my complete factorization there. Now that I know my factors, I can find my zeros. So, factors. So, setting each factor to 0 and solving for x will give me my zeros. So I have x equals 1, x equals negative 1, x equals 2, x equals negative 2. Notice that each one of these is only listed once, so the multiplicity is odd for each one of them, because 1 is an odd number. That means at each 0, the graph is going to go through that 0, not bouncing on it. So you have 1, negative 1, 2, and negative 2. It's kind of hard to draw it, but we can make it work. What is the y-intercept? If you put 0 in right here at x to the 4th and negative 5x squared, it's going to knock those out and leave me with just 4 left over. So I know that my y-intercept is going to be at 0, 4, which when I graph it is right here. Look at your multiplicity, not your multiplicity, I just did that. Look at your end behavior. So right here, the leading coefficient is positive. That means the right side is going to be going up. The exponent here is even. So it's our first even one there out of the 8 problems we've done so far, or 6 problems we've done so far. So the left side is going to be going up. And so now when I go to graph this, I know it goes through all the intercepts. It's coming here. It's got to go through that y-intercept. So I'm going to come from this side, go through, come back up. It's got to go through that y-intercept, come back down, and then go back up. Is this the max value here? I don't know. It could go up a little bit higher and then come back down. I just thought it doesn't matter because right now I'm not requiring that of you, and it looks like a W, which I think is kind of cool. All right. So let's try out the next one and the last one on the worksheet. So this one, we've got 1, 2, 3, 4, 5 terms. Just beautiful. It goes 4, 3, 2, 1, 0, so I don't have to put any placeholders in. All I need to do is list out factors of negative 12 and start dividing it out. The leading coefficient's 1, so I don't have to really worry about making the fraction or anything like that. So I've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. I believe I've got all of them covered there. List out your coefficients of 1, negative 1, negative 13, 25, and negative 12. I'm going to try 1 first. Oh, look at that. That's nice. So x minus 1 is a factor because 1 is a 0 of it. That leaves me with the degree of the function was 4, so that means this is x cubed plus 0x squared minus 13x plus 12. Now, what we will have to do, though, is divide this thing again. So now we're going to repeat the same process. Oops, not like that. We're going to repeat the same process with these as my numbers. I'm going to take and write out these coefficients, 1, 0, negative 13, and 12. And I'm going to try to divide it by 1 again, or by x minus 1 again, see if 1 is a repeated 0. So drop the 1. And look at that, it is. So drop the 1, 1 times 1 is 1, add, 1 times 1 is 1, add, 1 times negative 12 is negative 12, and we get a 0 there. So that means that x minus 1 will divide into this, to the function again. So we got x minus 1, and this is now an x cubed, so this is going to be 1 degree less. It's going to be x squared plus x minus 12. So let's erase this now. And so this is one of the first times we've come across this. This mess divided by x minus 1 gave me this. So I can replace all of this mess up here with what I got right here. Because if I multiplied x minus 1 times this, I would get what I just deleted. If I took x minus 1 times x minus 1 times x squared plus x minus 12, I'd get number 8, or whatever that function, whatever they're calling that function right there. Now I'm still not done completely factoring it because I'm still left with a quadratic there. So I'm going to go ahead and see if this trinomial will now factor. So 1 times negative 12 gives me negative 12, and factors of negative 12 that add up to 1, I've got 3 and 4. If you make the 3 negative, that will work. The leading coefficient's 1, so I can take the shortcut and say that's the same thing as x minus 3 times x plus 4. And now I can replace that trinomial with its factored form. So those are my factors. I need to list out the zeros now. So the zeros are found by setting each factor equal to 0. So you get x equals 1. That's a repeat, so I don't have to do that one again. X equals 3. And x equals negative 4. When I talk, well, let's go ahead and just plot those points. We got 1, negative 4, and 3. When I look at the multiplicity, 1 came from the x minus 1. That's listed twice. That's an even number, so it's going to bounce there. 3 came from x minus 3. That's listed once, so it's going to go through. X equals negative 4 came from x plus 4. That's listed once, so it's going to go through there. When I look at the end behavior, for the end behavior, the leading coefficient is 1. That's positive. It's going to be going up. And the exponent here is 4. The degree of the function is 4. And so that's going to be even. And so it's going to match the right side. So it also is going to go up on that side. Pay attention to your y-intercept. Y-intercept happens when x is equal to 0. If I put 0 in, this becomes 0, becomes 0. 0, 0, it crosses at negative 12. So the y-intercept is at 0, negative 12. So now I've got some stuff to graph here. I know it's coming from the top left right here. At negative 4, it goes through. It's going to drop all the way down below to wherever negative 12 is. And then after somewhere in there, it's going to come back up. It's going to bounce at 1 and then go through 3 and match with that right there. So let's draw that. So we're going to go the top. It's not going to cross until it hits negative 12. It's kind of hard to draw sometimes when it's so steep. I'll try to draw it again. Let's see. Down like this, through the negative 12 point, and very sharply. See? I'm trying to draw it like I want you to draw it, where it doesn't cross 1 until it's the 0. Try not to make it a vertical line. And then right here, remember at 1, it's going to bounce. It's going to bounce, and then somewhere in between 1 and 3, it's going to shoot back up and go through 3 right there. Put arrows on the end to let me know you know it goes on forever. And so that's close enough where you can call that a winning graph right there, a winning drawing. All right. So hopefully you didn't have to listen the whole hour of me. And if you did, that's great. I hope you do awesome on your quiz just for that. And I hope that these videos are helping you. All right. Good luck on your quiz, and thanks for working hard in the class.